Today we will start probability theory chapter. Right. So let us first know some basic definitions from probability theory. Experiment. An experiment is the process by which an observation is obtained. Event. An event is an outcome of an experiment. So that means when we do an experiment, we get different types of outcome. So an event can be an outcome or can be multiple outcome. That means when an experiment is performed, a particular event either happens or it doesn't. So if we see some example, we will get a clear idea. For example, tossing a coin. So this is a kind of experiment. So if you toss a coin, you may get either head or tail. So you don't know what you will get. So this is an experiment, that what you will get from tossing a coin. So from tossing a coin, you can get two outcomes, either head or tail, but you don't know what you will get. So that means there is a chance that you may get head or you may get tail. There is a 50-50 chance. So that means probability of getting head is 50%, probability of tail is also 50%. That means probability of head is 0.5, probability of tail is also 0.5. So let's see the next one. Select a good or product for inspection. That means, for example, you got a shipment. Now you want to check whether the products are good or not. So, or maybe you received a delivery from a online shop. So you want to see whether the goods are okay or bad. So there can be, this is an experiment, so there can be either of two outcomes. The product can be defective or not defective. Conduct a sales call. So if you, for example, you are working for a call center of a sales of a automobile shop, or maybe you are working as a sales agent. So you performed a sales call to a customer, to a potential customer. So that customer may purchase or may not purchase. So that means there can be either of two outcome. The customer may decide to purchase or customer may not purchase. Roll a dice. So most of you played Ludo in online or in the using Android app, or maybe using Ludo board also at home. So in Ludo, you roll a dice. So that means in Bengali we call it chokka. So that means dice is, we call it in Bengali chokka. So when you roll a dice, there can be either of 6 outcomes. That means there can be, you may get 1, 2, 3, 4, 5 or 6. So you can get either of these 6 outcomes. Okay. So getting each outcome, there is a chance that you may get 1. The probability of getting 1 is 1 upon 6. Probability of 2 is also 1 upon 6. That means if the dice or the chokka is unbiased, there is an equal chance of getting 1, 2, 3, 4, 5, 6. That means probability of getting each of these outcome is same. So when you play a football game, there can be either of these 3 outcome. You may win, or you may lose the game, or there may be a tie, that means draw. An event. An event is a collection of one or more simple events. That means an event can be only one outcome or a set of outcomes. Roll a dice. So Ludo, in Ludo game, when you roll a dice, that means chokka. For example, event A is getting an odd number. So let us define getting an odd number as event A. So getting an odd number, that means 1, 3 or 5. That means when you roll a chokka or dice, you may get the odd numbers are 1, 3 and 5. So these are multiple outcomes. So all these 3 outcomes constitute event A. So that means event A, the event set A or event A is 1, 3 and 5. Let's see, getting a number greater than 2. We define it as event B. So that means getting a number greater than 2 from rolling a dice. So that means you may get 3, 4, 5 or 6. That means we are defining it as event B. Now let us move to page 2. So A union B, we pronounce this one as union. In set language we pronounce this one as union. So A union B, that means common and uncommon outcomes between event A and also event B. That means common and outcome, everything we will take. So let us check what we have in event A and B. So that means this is event A. Event A we have 1, 3, 5. Event B we have 3, 4, 5, 6. Here 1 is uncommon, we will take it. 2 is not there, so we will not take it. 3 is common, so that means we will take this one. 4 is uncommon, we will also take it. 5 is common, we will take it. 6 is uncommon, we will take it. So that means we will have 1, 3, 4, 5, 6. So that means A union B will be 1, 3, 4, 5, 6. Now this one is A intersection B. This sign is called intersection. So A intersection B, that means we will take only common outcomes between A and B. So that means we will take only, intersection means only common things. So let's see what we have in common in event A and B, between event A and B. So see 1 is not there. So 1 is not common, we will ignore it. 3 is common between the both sets, so we will take it. Again 5 is common, we will take it. So 3 and 5 are the only common outcomes between set A and B, event A and B. So we will take, that means A intersection B is 3, 5. So A superscript C or A prime is called complement of event A. That means outside the event A. That means we will take all the elements outside the event A. So that means we will take all the elements outside the event A. So let's see what we have in event A. In event A we had 1, 3, 5. So outside 1, 3, 5, other than 1, 3, 5, we have 2 and then 4 and 6. So that means A complement set. A complements means, so AC or A prime means the remaining elements that we didn't include in event A. That means 2, 4, 6. Now let's check the next example. So example, select a student from the class room and record his or her hair color and gender. So let's see, event A is student has black hair. So A complement is student does not have black hair. That means if event A means student has black hair, that means A complement will be the students who does not have black hair. So that means if event A is student with black hair, so that means A complement set is, A complement event is student who does not have black hair. So event B is student is female. So obviously the opposite of B is student is male. So we name it as C, or maybe this one is also can be also name it as B prime or BC. Now as you can see, B intersection C, that means common outcome between B and C. That means whether a student have any whether there is any student with common gender. Let's see, let us assume that there is no student with common gender. So that means there is nothing common between event A and C. So that means B intersection C is null. That means this one is called null. That means nothing. So that means mutually, that means event B and C will be called mutually exclusive event. That means we are assuming that a student can be either male or female, right? So B union C, that means either male or female. So that means that means we are taking all students. That means a student can be either male or female, right? So that means we are, this here union means common and uncommon. That means we are taking everything. That means all students. So right, let us move to page 3. Counting rule for multiple step experiments. If we toss 2 coins as a sequence of first tossing 1 coin, that means when you toss 1 coin, you may get either head or tail. That means total outcome is 2. Then tossing the other coin, if you toss the other coin, you can get head or tail. That means you can get another 2 outcome. So we can see from the counting rule that if you toss 2 coin, the total outcome can be 2 multiplied by 2. That means from tossing 1 coin you can get 2 outcome, from tossing other coin you can get another 2 outcomes. So that means 2 multiplied by 2, you can get total 4 distinct experimental outcomes are possible. So let us explain this one with a tree diagram. So here in the step 1 we are tossing first coin. So when you toss first coin, you may get either head or tail. That means let us denote head as H, let us denote tail as T. So this is the outcomes, 2 outcome we can get from tossing coin for the first time. So if you toss a second coin, you may get head. That means let's see when you toss the coin for the first time, you got head. So when you toss second coin, you may get again head or tail. So that means you may get head from the first coin and head from the second coin. That means you may get head, both head. So that means if you get head from the first coin, you may get head also from the second coin. That means you may get both head from the 2 coins. So you may get head from the first coin and tail from the second coin. That means you may get head from the first coin and tail from the second coin. So again, you may get tail from the first coin and head from the second coin. So that means tail from the first coin and head from the second coin. You may get tail from the first coin and also tail from the second coin. That means you may get tail from the first coin and tail from the second coin. So that means total number of outcomes are 4. That means head, tail, head, tail. So that means 4 outcomes can be possible from tossing 2 coins simultaneously. So now let us move to page 4. Probability of an event. The probability of an event A measures how often we think A will occur. So we write probability of A as P bracket A. So that means probability of A can be written like this. So probability of an event must be between 0 and 1. That means maximum probability can be 1 or the minimum lowest probability can be 0. If an event A can never occur, that means the probability is 0. That means if an event can never occur, we will say that probability is 0. If an event A always occurs, that means if there is a chance that it will always occur when the experiment is performed, that means we will call it probability of A is 1. That means if you are 100% sure that event A will always happen, event A will always occur, then probability is 1. That means maximum probability we can get 1, the lowest probability we can get is 0. The sum of the probabilities for all the experimental outcomes must equal 1. That means sum of the probabilities for all the experimental outcomes must equal 1. Right. So rolling a dice in Ludo game. So that means when you roll a dice or chokka in Bengali in Ludo game, you may get either 1, that means probability of getting 1 is 1 upon 6. That means you can get 1, you may get, you may get 1, you may get 2, you may get 3, you may get 4, you may get 5, you may get 6. That means there are total 6 sides of a dice in Ludo game. So that means you may get 1, you may get 2, you may get 3, 4, you may get 5 and 6. So that means each one has, if the dice is unbiased, that means if you haven't scratched it, or that means if you haven't scratched it, if you haven't scratched the dice, if you haven't made the dice unbiased, if the dice is unbiased, that in that case all this outcome should have equal chance. That means probability of getting 1, probability of getting 2, probability of getting 3, 4, 5 and 6 should be same. That means each one have probability 1 by 6, 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 1 by 6. So how we get it? 6 is the total number of outcomes. 6 is the, so in the denominator we will have total number of outcomes. So 6 is the total number of outcomes, and over on the numerator we will have, see, 1 is only one outcome, so we will have 1. So 2 is only one outcome, so we will have 1, and this is the total outcome. So like that way each one have equal probability. So as you can see, if you add probability of each of these outcome, you will get 1 upon 6, 1 upon 6, 1 upon 6. If you add all these, your total probability will be always 1. Right. So now let us move to page 5. Now let us move to page 5. Example. Toss a fair coin. So if you toss a fair coin, probability of getting head is 1/2. Why? So if you toss a fair coin, that means coin is not scratched, coin is not manipulated to get a particular side. In that case we will call that coin a fair coin. If that coin is fair or good, in that case you may get either head, you may get either tail. That means getting head and tail has equal probability. That means getting head is probability of getting head is same like probability of getting tail. So that means probability of head, that means because we have two outcome, so 2 will be in the denominator and head is only one outcome, we will have 1 over. So that means probability of getting head is also half, probability of getting tail is also half. So let's see the next example. 10% of the US population has red hair. So 10% of the US population has red hair. So if you select a person randomly from US, probability of getting red hair, probability of getting a person with red hair should be 10%, because 10% of the US population got red hair. So if you select a person in the United States randomly, in that case probability of getting a red hair, a probability of getting a person with red hair is 10%, that means 0.10. So next example, toss a fair coin twice. What is the probability of observing at least one head? So as you know already, total number of outcomes from tossing a fair coin twice. So if you toss a coin one for the first time, you will get 2 outcomes. If you toss the coin second time, you will get another 2 outcomes. So total outcomes can be 4. That means you can get head. That means you can get head twice. You can get head in the first. You can get head first time and tail second time. You can get tail first time, head second time. You can get tail first time and tail second time. So that means there can be total 4 outcomes. Probability of at least one head. As you can see here, at least one head. That means minimum one head. So this one qualifies. This one got 2 head. That means at least one head is there. This one also has at least one head. This one has also at least one head. That means total 3 outcomes. That means observing at least one head. That means we have total 3 outcomes of this event. So 3 outcomes are there. So the probability of at least one head, since we have total 3 outcomes there, and total number of outcome is 4. That means we have total 4 outcomes, and out of total 4 outcomes we got 3 times. We got 3 outcomes that has at least one head. So probability is 3 by 4. Now the next example, a bowl contains 3 M&M chocolates, right? So a bowl contains 3 M&M chocolates. It's a very favorite chocolate, right? A bowl contains 3 M&M chocolates, one red, one blue and one green. A child selects 2 M&M, that means 2 M&M chocolate at random. That means a child selects 2 M&M chocolate randomly. What is the probability that at least one is red without replacement? That means after that means child will select 2 chocolate from the bowl. He will select 2 chocolate randomly. That means he will not have a chance to choose. That means we need to find out that what is the probability that at least one of these 2 chocolate is red without that means chocolates are selected without replacement. That means when the boy select the first chocolate, he will eat it. He will not return the chocolate to the bowl. That means he will not replace the chocolate in the bowl. So that means, right. So first M&M, as you can see, first M&M, that means when the child will select one chocolate, it can be either red, it can be either blue, or it can be either green, because we have one red, one blue and one green. So that means the chocolate can be red, chocolate can be blue, chocolate can be green. The first one. Second one can be blue, can be green, because red has been already chosen, because since we have only one red, we had only one red in the bowl. So that means since if the child has already chosen red chocolate for the first attempt, in the first attempt if the child has already chosen the red chocolate, that means red chocolate is already gone from the bowl. That means the bowl has only blue chocolate and green chocolate. So in the second time, since you know that child will select 2 chocolate, that means for the second chocolate he has only blue or green. That means he may get blue or green. So if he choose blue, he will get red. That means the outcome is RB, R for red and B for blue. If he choose green, the outcome can be RG. That means red, first chocolate is red, green is second chocolate. Similarly, if the first chocolate is blue, in that case the second chocolate can be red or green. That means BR. That means first chocolate blue, second chocolate green, second chocolate red, first chocolate blue, second chocolate green. So like that way we may have total 6 outcomes. So we may have total 6 outcomes. Since the child will select the chocolate randomly, that means without any biasness, so all this outcome will have equal chance. That means all this outcome will have same probability, 1 upon 6, 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 1 upon 6. Since 6 is the total outcome, we will have 6 in the denominator, and this one is only one outcome, so we will have 1 by 6. So like that way all the probabilities are same, and if you add all these, you will get 1. You will get total probability is always 1. Now let us move to next page 6. Probability that the question was asking us to find out probability that at least one is red. That means at least one is red. As you can see from this tree diagram, we can see this one qualifies because it has at least one red. This one also qualifies, it has at least one red. This one also at least one red is there. This one no red, that means it doesn't qualify. This one qualifies because it has at least one red. This one does not. That means this one at least one red. This one also at least one red. This one also at least one red. This one also at least one red. That means out of total 6 outcome, 4 outcomes has at least one red. That means out of 6 outcome, 4 outcomes got at least one red. So that means that means you can see these are the outcomes. That means probability of these one is 1 upon 6, 1 upon 6, 1 upon 6, 1 upon 6. As you can see, out of total 6 outcomes, we have 4 outcomes with at least one red. So 4 divided by 6. So if you reduce it, we get 2 by 3. Alternate method. We can solve the same problem in a shortcut method. So since the child will select two chocolate out of total 3 chocolate, so probability of at least one red is this way we can solve it. So in the numerator we will first do, see, the child will select 2 chocolate. So first, since we need to select at least one red. That means you can see from the question, in the ball we got 3 chocolates, 1 red, 1 blue and 1 green. That means only 1 red is there. That means the child cannot select 2 red. Child can select only 1 red. That means probability of at least 1 red means child can select only 1 red. He cannot select more than 1 red because the ball contains only one red chocolate. So select 1 red chocolate out of 1 red. Only 1 red chocolate is there in the ball, and the child has to select 1 red chocolate out of 1 red chocolate. So the child need to select another chocolate because the child will select 2 chocolate. So child need to select 1 chocolate out of the remaining 2. The ball contains total 3 chocolates. Since he has chosen 1 red already, so the ball will have only 2 more chocolate left. And since the boy need to select 1 more chocolate, so select 1 more chocolate out of the remaining 2 chocolate. And as you can, as total number of outcome in the denominator, we will have always total number of outcome. So total number of outcome we can get it like selecting 2 chocolates, because since the child has to select 2 chocolate out of 3. So selecting 2 chocolate out of 3. So selecting 2 chocolate out of 3 chocolate, we can do it in 3C2 way. So that means 3C2. That means this is combination 3C2. Selecting 1 red chocolate out of 1 red chocolate, we can do it in 1C1. Selecting 1 chocolate out of the remaining 2 chocolate, we can do it as from the 2 chocolate we need to select 1 chocolate. That means 2C1. So if you use your calculator, you can solve it very easily. So to solve this one, you will press 1 first and then press shift in your calculator. Press shift in your calculator and then press division sign. That means you will first press 1, then shift in your calculator and then division sign and then press 1. So you will get 1C1 there, and press equal, you will get 1. To find out, to calculate these one, you need to first press 2 and then shift division sign to get the combination sign, that means C, and then you will press 1, you will get 2C1, and then press equal, you will get 2. Similarly, you can solve this one also, you will get 3. So that means 2 divided by 3. That means answer is 2 divided by 3. That means you can solve it in without the tree diagram. Same problem, same answer. So this one you can solve in this method. We are solving it without the tree diagram, and the previous method we solved it using the tree diagram. So you can solve it with tree diagram. You can solve it without the tree diagram as well. Now we will move to page 7. So let's see what we have in this example. A box contains 6 M&M chocolates, 4 red and 2 green. A child selects 2 M&M chocolates at random. What is the probability that exactly one is red? So this time we have 6 chocolate total. Out of these 6 chocolate, we have 4 red and 2 green, and then the child need to select 2 M&M chocolate randomly. So probability of exactly one red, right? So That means the child need to select one red chocolate out of 4 red chocolate. So that means child need to select one red chocolate out of 4 red chocolate. That exactly one red. That means child need to select one red chocolate out of 4 red chocolate. That means since the child need to select 2 chocolate, that means child will select one more chocolate. That means select one more chocolate out of 2 green. That means the child already selected one red chocolate out of 4 red chocolate, so only 2 green chocolate is left. That means he need to select one more chocolate out of 2 green chocolate. So that means selecting one red chocolate out of 4 red chocolate means 4C1 multiplied by the child need to select one more chocolate out of 2 green chocolate. So selecting one green chocolate out of 2 green chocolate is 2C1. Total number of outcome is, since the child need to select total 2 chocolate out of total 6 chocolate, that means selecting 2 chocolate out of total 6 chocolate, that means 6C2. So if you solve it using calculator, you press 4 first and then shift and then division, then you will get C, and then you press 1, so you will get 4C1, and then press equal, you should get the value. So like that way, if you solve all these, you will get this one is equal 4, this one is 2, and 6C2 means 15, so that means the answer is 8 by 15. So probability of exactly one red means probability is 8 by 15. So now see probability of at least one red. So if you want to find out probability of at least one red, so the child need to select total 2 chocolate. That means the maximum, that means probability of at least one red means the child may select one red chocolate and the child may select 2 red chocolate. That means since the child will select 2 chocolate out of 6 chocolate, so the both chocolate can be red. So that means we need to find a probability of at least one red, means we need to find probability of one red chocolate, and also we need to find probability of 2 red chocolate. So similarly, so probability of one red chocolate is same like this way. So that means 4C1 2C1 divided by 6C2. That means 4C1 2C1 divided by 6C2. This one is like before. So plus, so we need to select, now we need to find out probability of 2 red chocolate. That means we need to select 2 red chocolate out of total 4 red chocolate. That means we need to select 2 red chocolates. So because the probability is 2, for we need to find out, we need to find probability of 2 red chocolates. So that means we need to find out, we need to select 2 red chocolate out of 4 red chocolate, and then since the child will select 2 chocolate in total, so since the child already selected 2 red chocolate out of 4 red chocolate, that means only 0 chocolate is left to select. That means select 0 chocolate out of the remaining 2 green chocolate. So that means selecting 2 red chocolate out of 4 red chocolate is 4C2. Selecting 0 chocolate out of 2 green chocolate is 2C0. Divided by selecting total 2 chocolate out of 6 chocolate is 6C2. So if you do it using calculator, this one is same like before, 8 by 15, 8 by 15, and this one is 4C2 is 6, 2C0 is 1, and 6C2 is 15. So 8 by 15 and here 6 by 15, so in total is 14 by 15. So probability of at least one red is 14 by 15. Now we will move to page 8. Probability of complement. So if this is the event A, so AC is outside A. So that means this one is AC. So probability of A intersection A complement, that means if there is anything common between say event A and event AC. So as you can see, this is event A and AC is outside event A. So that means there is nothing common. So that means probability is 0. So probability of A union AC. So that means you from set theory we know that union set means probability of A plus probability of AC. Union means probability of A plus probability of AC minus probability of A intersection AC. This is the formula for union. So union means probability, we will take the individual probabilities, that means probability of A plus probability of AC, we will add this, and from these we will deduct probability of A intersection AC. Since either A or AC must occur, so you can see you can only get A or AC, you cannot get both, because AC is complement of A. So that means you can only get A or AC but not both. So that means there is nothing common between say event A and AC. So that means probability of A intersection AC is 0. So this part is 0. So which means probability of A union AC is this one and this one. So probability of A plus AC. So which means total probability is 1, because you know that since either A or AC must occur, that means you can either get this one or this one. So that in that case total probability is obviously 1. So that means total probability is 1, and you know already this one is 0. So that means probability of A plus probability of AC is 1. So if you that means probability of AC is 1 minus, if you take this one in this side, so 1 minus probability of A, that means probability of A complement is 1 minus probability of A. So which means if you know probability of A, in that case total probability, since you know the total probability can be maximum 1, so if you know probability of A, you can find out probability of AC from this formula. So 1 minus probability of A. So let's see one example. If the probability of A is 0.7, then probability of AC is, you know, the total probability can be 1. So if probability of A is 0.7, obviously probability of A complement, that is AC or A prime is 0.3. Right, so we will move to page 9 now. So we have an example here. So as you can see, so here we have data of some students here. So here we have 20 students, those who have brown hair, 20 male students. We have 20 male students here with brown hair. We have 40 male students here with not brown hair, that means they may be black. So total male students we have is 60. 40 plus 20, total we have 60 male students. Similarly, we have total 60 female students. So 30 female students with brown hair and 30 female students with not brown hair. So total 30 plus 30, total 60 female students. Here we can see we have total 50, 30 plus 20, we have total 50 students with brown hair. We have total 70 students with not brown hair, and so 70 plus 50, total 60. Again this way if you add, you will get 120. So the question is asking, select a student at random from the classroom. So we will need to select a student randomly from the classroom and find the probability of selecting a male student. So we need to select a student randomly from the classroom, and we need to find out the probability that the student will be a male student. So as you can see, the total student is 120. Always total student will be in the denominator, and here we want to find out the probability of a male student. So we have total male student is 60. So male student will be on the numerator. So total male student is 60 and total student is 120. So that means we have 60 male student out of 120. So to 60 male student out of 120. So probability that the student will be a male is 60 divided by 120. So this is half, that means 0.5. So obviously probability of female, that means probability of male is a probability of female is a complementary event of probability of male, because a student can be either male or female. So if the probability of male student is 0.5, obviously probability of female student should be also 0.5. So probability of female student is 1 minus 1 minus 0.5. That means this one is 0.5. That's why 1 minus 0.5 is 0.5. Right. So the third question is asking, find out the probability of selecting a student with brown hair. That means if you select a student randomly from the classroom, you need to find out the probability that the student will have a brown hair. So as you can see, we have total 50 students with brown hair out of 120 students. So obviously 50 divided by 120. So that means 5 divided by 12. So that means probability of selecting a student with brown hair is 5 by 12. Now we will move to page 10. We will move to page 10. Right. So number 4. Find out the probability of selecting a male student with brown hair. With brown hair. That means you need to find out the probability that the student is male, at the same time student has brown hair. So you can see this is we have 20 students who are male student as well as with brown hair. So that means we have 20 male students with brown hair. So out of 120. So you can see we have total. So probability of selecting a male student with brown hair is 20 divided by 120. That is 1/6. So now find out the probability of selecting either a male student or a student with brown hair. So that means whenever you see the question is asking either or. So if you see either or, that means this is question is asking you to find out the union. That means whenever you see either or, that means you need to do union. That means probability of selecting either male student or a student with brown hair. That means this is a union. You need to find out the probability of union between male and brown. So male is, you know that male we denote it by A, and brown is we denote it by B. You can see from here, male is A and brown is B. So that means we need to find out the probability of A union B. So that means probability of A union B, the formula is probability of A plus probability of B minus probability of A intersection B. That means common part. So probability of A we have already calculated it. Probability of A is 0.5. Probability of A is 0.5. Probability of B is 5 by 12. So probability of A is half. Probability of B is 5 by 12. So probability of A is half. Probability of B is 5 by 12. And probability of A intersection B is 1/6. So if you deduct, you can see the LCM. LCM means in Bengali we call it Loshagu. So LCM, least common multiple, is 12 among these. So 12, if you do it, if you solve it, the answer is 3 by 4. So that means probability of A union B is 3 by 4. Right. So let us move to next question now. A sales manager who, after reviewing sales reports, states that 80% of new customer calls results in no sale. So that means sales manager observed that when they call customer over phone, they have seen that 80% of new customer calls, if they make 100 calls to customers, only 20% customers buy their product. That means 80% of new customer calls results in no sale. So let's see, probability of sale is PA. So obviously probability of no sale is probability of no sale should be AC. If the probability of sale is P, probability of A, then probability of no sale is probability of AC. That means complementary event. So sale is A, no sale is AC. That's right, or A prime. So as you can see, probability of no sale is 80%. Probability of no sale is 80%, that means 0.8. So obviously probability of A will be the remaining. So that means you know that total probability is always 1. So probability of A will be 1 minus probability of A prime. That means complementary one. So 1 minus 0.8, 0.2. Right. So now we will move to page 11. So we have a table here. We can see an operation manager. He tried to collect data about the operation people, about the assembly people. He has seen that workers who completed a particular work late is 5. That means he has observed that the operation manager has observed that 5 employees or 5 workers used to complete work late out of total 50 workers. That means out of total 50 workers, 5 workers complete work late. That means, let's see, we denote this event as A. That means completing work late, we are denoting it as event A. So obviously, and in this information is the assembled defective product. So out of 50 workers, 6 workers assembled defective product. So out of 50 worker in total, out of 50 workers, 6 workers assembled defective product. So and 2 workers out of 50 workers, 2 workers, they are late in finishing their product. Also they finish defective product. That means they are too bad. So the question is asking, fill out the empty cells of the table. So we need to fill out the empty cells of the table. As you can see, this one is out of 50 workers, 5 workers, they are late in finishing their product. That means they are out of 50 workers, 5 workers are late in completing work. So obviously the remaining, that means 45 workers, they are not late. So 45 workers, they are not late. Again, here out of 50 workers, 6 workers assembled defective product. That means only 6 workers assembled defective product out of 50. That means 50 minus 6, that means 44 workers produced not defective product. That means those products were good. That means if 6 workers produced assembled defective product, that means remaining 44, they assembled not defective product. That means 44. Again, here, if this one is 2, this one is 2, so obviously this one is total is 5, so this one will be 3. So this one will be 3. Again, if this one is 2, total is 6, so this one is be 4. This one will be 4. Again, if this one is 45 and this one is 4, so obviously this one will be 41. This one will be 41. Again, if this one is 50 and this one is 6, obviously this one is 44. So this way you can fill out the table. Now the question is also asking to find out probability of workers completed work late. So as you can see, total 5 workers completed work late out of 50. So that means probability of workers completed work late will be 5 divided by 50, which is 1 upon 10 is equal to 0.10. Next question is asking, find out the probability of workers assembled defective product. We can see from the table number of workers assembled defective product is 6. So there are 6 workers who assembled defective product out of 50. So probability would be 6 divided by 50. 6 divided by 50. So you can, if you reduce it, we get 0.12. So this is probability of B. That means defective product is even B and late is A. So not defective is obviously B prime and not late is A prime. So now the question is asking, find out the probability that workers completed work late and also assembled defective product. So find out the probability that workers completed work late and also assembled defective product. So whenever you see the word and is there, or both is there, both or and is there. If you see the word both and, that means you need to find out the intersection. That means probability that workers completed work late and worker completing work late is event A, and also assemble defective product. Assembling defective product is event B. So that means you need to find out the A probability of A intersection B. As you can see here, only 2 workers were late in completing their work. Also they produced defective work. So that means only 2 workers out of 50 were late in producing, and also they assembled defective products. So 2 divided by 50 is 0.04. Now let us move to page 12. The production manager decided to assign a poor performance rating to any employee whose work was either late or defective. So the production manager operation manager decided to assign a poor performance rating, that means bad grade, to those employees whose work was either late or defective. As I said before, if you see the word either or, that means this is union. You need to do the union. So that means assign a poor performance rating to any employee whose work was late. Late means the late means event A, defective means event B. Since you see that the word either or is there, so that means you need to find out the A union B. That means you need to find out the probability of A union B. So as I said before, the formula for A union B is probability of A plus probability of B minus probability of A intersection B. That means common part of A and B. So we have already calculated probability of all these. From the previous page we can see probability of A is 0.1, probability of B is 0.12, and probability of A intersection B is 0.4. So we will put those values there. See, you can put those values there, and if we calculate we get 0.18. That means there is a 0.18 or 18% chance that a randomly selected employee received a poor performance rating. That means out of 50 employee or 50 workers, if you select a worker randomly, there is a chance that there is an 80% chance that that worker will be bad or will receive poor performance rating. So let's see the exercise. We have exercise here. This exercise is saying that a personnel manager is normally an HR manager. So a personnel manager of a major computer software company made a survey and found that 30% of the employees who left the firm within 2 years did so primarily because they were dissatisfied with their salary. That means the personnel manager or HR manager of that computer software company had made a survey to find out that why employees are leaving within 2 years. So he has seen that 30% of the employees who left the firm within 2 years did so primarily because they were dissatisfied with their salary. 20% left because they were dissatisfied with their work assignments, and 12% of the former employees indicated dissatisfaction with both their salary and their work assignments. So what is the probability that an employee who leaves within 2 years does so because of dissatisfaction with either salary or with work assignment? So as you can see here, let us denote leaving the company. Let us denote event A as the employees who left the company within 2 years due to dissatisfaction with the salary. That means let us denote event A as the number of employees who left the company due to dissatisfaction with their salary. So that means probability of A is 30%. So let us denote event B is the number of employees who left the company within 2 years due to dissatisfaction with their work assignments. So probability of B is 20%. and 12% of the former employees indicated dissatisfaction with both. As I said before, whenever you see the word both and, so that means this is union set. So let me read out again. 12% of the former employees indicated dissatisfaction with both their salary and their work assignment. So that means 12% employees, they leave the company due to dissatisfaction, because they were dissatisfied with both salary and work assignment. That means 12% employees leave the company within 2 years because they were dissatisfied with both salary and work assignment. As you know that the salary part we denote it as event A. That means those who left the company due to salary, due to dissatisfaction with their salary, this is event A. And the employees who left the company due to dissatisfaction with the work assignments, this is event B. As you can see, both is there. That means 12% employees left the company because they are dissatisfied with both. So that means this is union set. That means A union B is 12%. That means probability of A union B is 12%. Now the question is asking, what is the probability that an employee who leaves within 2 years does so because of dissatisfaction with either? As I said before, whenever you see the word either or, that means you need to find the union set. The question is asking to find out what is the probability that an employee who leaves within 2 years does so because of dissatisfaction with either salary, that means event A, or with the work assignment, that means event B. That means you need to find out, whenever you see either or, that means you need to find out the union set. That means A union B. That means you need to find out the probability of A union B. Right. So let me solve it. So employees left the firm within 2 years due to, let's see, event A, that means probability of A, that means event A is dissatisfied with their salary. So event A is dissatisfied with their salary, and as you see, 30% employees, they are leaving the company they left the company within 2 years due to dissatisfaction with their salary. That means probability is 0.30. 20% employees left the company within 2 years due to dissatisfaction with their work assignments. So probability of B is 20%. And 12% employees, they left the company within 2 years due to dissatisfaction on both salary and work. So whenever you see both and, that means unions, intersection, that means common. That means A intersection B. The probability of A intersection B is 12%. The question is asking us to find out the probability of A union B. That means dissatisfaction with either salary or with work assignments. So whenever you see either, that means union set. So probability of A union B, that means probability of A plus probability of B minus probability of A common B, that means A intersection B. So if you put the values there, the answer is 0.38, that means 38%. That means 38% employees, they left the company because of dissatisfaction on either salary or work assignment or both. So now let us move to next exercise. 2 unbiased dice. The dice means chokka. In Bengali we call it chokka in Ludo game. So 2 unbiased dice are tossed simultaneously. What is the probability of getting a total of 0.8 or even numbers from both the die? As I've said before, whenever you see or either, that means you need to find out the union set, right? So we are tossing 2 dice. As you know already, in Ludo game, whenever we throw a dice, there can be either of 6 outcomes. That means we can get 1 or 2, 3, 4, 5 or 6. That means total 6 outcomes are there. So since we are tossing not 1 dice, we are tossing 2 dice simultaneously. So from tossing 1 die, we get 6 outcome. So from tossing 2 dice, we will get 6 into 6, total 36 outcomes. Right. So let us denote event A as an event of getting a total of 0.8. That means we need to after we toss or roll 2 dice, we need to add the numbers of both the die. That means if we get, for example, from the first dice if we get 2, and from the second dice if we get 6, the summation is 8. So that means total is 8. So the question here, let us denote event A as an event of getting a total of 0.8. So you can see the question is asking what is the probability of getting a total of 0.8. That means let us denote as event A is the event of getting a total of 0.8. So how we can get 8 from 2 dice, from adding 2 dice? You can see if we get 2 from the first dice and if we get 6 from the second dice, the summation is 8. Again, if we get 3 from the first dice and 5 from the second dice, summation is 8. Again, if we get 4 from the first dice and 4 from the second dice, summation is 8. If we get 5 from the first dice, 3 from the second dice, summation is 8. If we get 6 from the first dice and 2 from the second dice, also summation is 8. So as you can see, total number of outcome in event A is 1, 2, 3, 4, 5. So we have total 5 numbers of outcome in event A, and total outcomes possible from 2 dice is 36. So that means probability of A is 5 divided by 36. 36 is the total outcomes we can get from tossing or rolling 2 dice. And event A has 5 outcomes, so 5 divided by 36. So probability of A is 5 divided by 36. Now let us denote event B as even numbers from both dice. As you can see, the question was asking us to find out what is the probability of getting a total of 0.8 or even numbers from both dice. So that means we need to also find out the probability of getting even numbers from both the dice. So let us denote even numbers. Let us denote event B as even numbers from both die. So that means in Bengali you call it jor shankha. So that means we need to find out, event B is the even number from both dice. So as you can see, this is even number, this is also even number. Let's see, we get 2 from the first dice, 2 from the second dice, so both are even. We get 2 from the first dice, 4 from the second dice, these are also both even. We get 2 from the first dice, 6 from the second dice, these are also even numbers. We can get, let's see, we get 4 from the first dice, 2 from the second dice, even numbers. 4 from the first dice, 4 from the second dice, even numbers. 4 from the first dice, 6 from the second dice, even numbers. Again, let's see, we get 6 from the first dice, 2 from the second dice, even numbers. 6 from the first dice, 4 from the second dice, these are also even numbers. 6 from the first dice, 6 from the second dice, these are also even numbers. So let's see how many outcomes are there in event B. In event B we have 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes. So probability of B will be 9 divided by total outcome is 36. So 9 divided by 36. Right. So now we need to find out the A intersection B. Because you know that to find out A union B, probability of A union B, the formula for probability of A union B is probability of A plus probability of B minus probability of A intersection B. So we already know probability of A, we already know probability of B, but we don't know these ones. So let us find these one. A intersection B, that means common part between event A and event B. So let us see the common parts between event A and event B. So this is event A. You can see here we have 2, 6. Here also we have 2, 6. So this outcome is common between two event. These outcomes here also 2, 6. Here also 2, 6. So these are the common outcome. This is the common outcome. Here also we have 4, 4. Here also 4, 4. 4, 4. This is the common outcome. Again, we have 6 plus 2, 6 and 2 here. We have 6 and 2 here. So you can see here this 2 is even number, these 2 is even number, and these 2 also even number, and here all are even number. So here, so even event A and event B, between event A and between event B, we have only these one and these one common. So that means only 3 outcomes are common, right? So only 3 outcomes are common between 2 events. So only 3 outcomes are common between 3 events. Only 3 outcomes are common between event A and event B. So probability is 3 divided by 36. So if you put it there, probability of A is this one, probability of B is this one, and probability of A intersection B is this one. If you calculate it, we get 11 divided by 36. So now we will study conditional probability. So conditional probability is the probability that A occurs given that event B has already occurred is called conditional probability of A given B. So I'm saying again, the probability that A occurs given that event B has already occurred is called conditional probability of A given B. That means B has already occurred. Now we need to find out the probability of A given that B has already occurred. So we can calculate it using this formula. So probability of A given B, this partition is, we pronounce it as given. So probability of A, so probability, this partition is called modulus sign. We will pronounce it as given. So probability of A given B is equal to probability of, on the numerator we will have probability of A intersection B. That means we will take the common part between A and B. That means probability of A intersection B divided by, in the denominator we will always have the probability of the given part. That means this one. So we will always have in the denominator we will always have the given part. So that means probability of B. And this formula only will work if probability of B is not equal to 0. That means probability of B cannot be 0. That means probability of B cannot be 0. If probability of B is 0, then this formula will not work, because if probability of B is 0, then we will get infinity or undefined. So again, you can see, if we write the formula in other way, so that means if probability of B given A, probability of B given A is equal to, as I said before, given part will be in the denominator. So this is the given part. A is the given part here, so will be in the denominator. And B given A, that means we need to find out the intersection between B and A. As you know that B intersection A or A intersection B, that means intersection means we need to find out the common part between event A and B. So doesn't matter we say common part between B and A or A and B is always the same. That means B intersection A or A intersection B is same. So that means we need to get the intersection or common part between A and B. So that means probability of A intersection B will be in the numerator, and always given part will be in the denominator. So now we can get another formula from this formula. So as you can see, if we do cross multiplication, here, this one multiplied by these ones will be equal to this one. As you can see, probability of A intersection B, probability of A intersection B can be written as this one multiplied by this one. So that means A given B into probability of B. So that means probability of A intersection B can be written as probability of A given B multiplied by the given part. That means probability of B. So if you write it in other way, you can see probability of A intersection B, probability of A intersection B is this one multiplied by this one. So that means if we write it, probability of B given A multiplied by that given part, that means probability of A. As you can see, both the formula is, let us resemble the both formula. So A intersection B, probability of A intersection B is probability of A given B multiplied by probability of given part. Again, probability of, it can be written as probability of B given A. If you write it like in the opposite way, probability of B given A multiplied by, in that case, probability of given part. That means given part is probability of A. Right. So now let us move to page 15. Right. So what we have in page 15. So let's see, we have an example here. Promotion status of male and female officers of a major metropolitan police force in the eastern United States is given there. So that means this data is the promotion status of male and female police officers of a major metropolitan police force of the in the eastern United States. Here let us denote M as an event where an officer is a man. So men can be denoted as event M, women can be denoted as event W can be defined as an event of woman. A, let's see, A is an event where an officer is promoted. So A is an event where an officer is promoted. So obviously if the officer is not promoted, should be A prime. So if the officer is promoted, if this is event A, so if the officer is not promoted, should be A prime. Right. So now as you can see here, promoted means event A, men means event M. So this is, that means there are 288 men got promoted. That means 288 men got promoted out of 1200. So that means men and promoted. That means men is event M, promoted is event A. That means this is the M intersection A. So M intersection A. So that means men and promoted. That means men is M, promoted is A. That means M intersection A is 288. So probability of M intersection A is 288 divided by total is 1200. So this is the probability. So that means probability that a randomly selected officer is a man who is promoted. That means both man and promoted. Again, this one is, that means 672 men not got promoted. That means men means even M, not promoted means A prime. So this is both men and not promoted. That means M intersection A prime is 672. So M intersection A prime is, probability of M intersection A prime is 672 divided by 1200. So this one. Okay. So now this one is woman. Woman means event W and promoted means A. So this one is 36 women got promoted. That means 36 women, 36 employees are women. Women means W and also got promoted. That means A. So this is the cell of W intersection A. W intersection A. That means these are the officers who are also W and A. That means W intersection A is 36. So W intersection A is 36 divided by 120. Right. So this is the probability. This one is the woman, number of women who not promoted. So that means 244 women not got promoted. That means woman means even W, not promoted means A prime. So this is the W intersection A prime. So 204. So W intersection A prime is 204 divided by 1200. So this is the probability. So now if you put the probability in the right cell, you can see this is 0.24, this is 0.56, so total is this one, again this one, total is 0.20, and total 0.03, 0.24, total is 0.27, and this one is 1, add total is 0.73, this one, total is 1, again if you add this one is 1. So these are the intersections, M intersection A, W intersection A, M intersection A prime, W intersection A prime, these are the intersections. That means joint probabilities. So these are called joint probabilities. So intersections are called joint probabilities, and these are called these two and these two called marginal probabilities. So that means this is the probability of M. That means if you select an officer randomly from that police station or that metropolitan police area, if you select a police officer randomly from that metropolitan police, probability that that officer will be a man is 80%. Probability that the officer will be a woman is 20%. Probability that the officer will be promoted is 27%. Probability that the officer is not promoted is 73%. So these are called marginal probabilities. Now, the question is asking probability that a randomly selected officer is promoted. Probability that a randomly selected officer is promoted. Promoted means event A, given that officer is a man. So given that officer is a man, that means event M. That means the question is asking to find out that so given part is men. Given part is men. So given part is men. So this is the given part. So given that officer is a man, that means given that officer is a man, we need to find out the probability that the selected officer is promoted. So we need to find out the promoted means event A. That means we need to find out the probability of A given that officer is a man. So given that officer is a man. As you know already, the formula is probability of A intersection M divided by the given part. That means probability of M. So if you put the values there, if you calculate, is 30%. Right. So another way we can calculate it is, you can see that that means here you are finding that actually this given part is actually you are finding that out of men, given that means out of men how many got promoted. That means out of men how many got promoted. As you can see, this is the total men, 960. Out of 960 men, 88 got promoted. So out of 960 men, 288 got promoted. So here actually in conditional probability we want to find out that out of men how many officers got promoted. That means out of men police officer how many got promoted. That means this is the total men police officer, and out of 960 male police officer, 288 got promoted. So you will get similar answer. See, 30%, here also 30%. So this is the two way of calculating conditional probability. So now probability that an officer got promoted given that the officer is a woman. So that means this one is the given part. That means probability that an officer got promoted given that the officer is a woman. That means in other way we can say it like how many women got promoted. That means how many police officers who are women got promoted. That means out of women police officer how many got promoted. We want to find out that. So that means as you know from the formula, A given W is probability of A intersection W divided by probability of W. So from the previous page you can see A intersection W is equal to 0.03. So 0.03 divided by probability of W. Probability of W is 0.20. Probability of W is 0.20. So divided by 0.20, which one answer is 0.15, that is 15%. So in other way you can do it is like that means out of out of women police officer, how many got promoted? As you can see here also from page 15, out of 240 women police officer, out of 240 women police officer, 36 got promoted. So you can, by doing these also you can find it. So 36 divided by 240, so that means out of 240 women police officer, 36 got promoted. So this is same answer, 50.15, that is 15%. So now let us move to next example. A bag contains 4 white and 5 red balls. 2 balls are drawn successively at random from the bag. So that means we need to pick 2 balls from the bag. What is the probability that both the balls are white? If the drawings are made with replacement or without replacement. So that means if you need to find out the probability that both the balls are white. You are out of 4, a bag contains 4 white and 5 red balls. That means 5 plus 4, total 9 balls are there. Out of 9 balls you have to pick 2 balls successively and at random from the bag. So you need to find out what is the probability that both the balls are white if the drawings are made with replacement and if the drawings are made without replacement. So let us solve the first part. Let A be the event that first ball is white. So since you are picking 2 ball, so let A be the event that first ball is white. Let B be the event that the second ball is white. So since the question is asking what is the probability that both the balls are white, so we are saying that we are denoting that event A is when the first ball is white. Event B is when the second ball is white. So now we will solve the first part with replacement. So with replacement, so that means both event A and event B are independent. Why? Because from out of 9 balls, when you pick 1 ball, after picking 1 ball, you are replacing the ball for when you pick the second ball. So that means out of 9 balls, when you pick your first ball, and for the second ball, before you pick the second ball, you are replacing the first ball. So that means when you pick the second ball, the balls are total number of balls are same 9 balls. So the total number of balls are same. So that means I'm saying again. So when you pick the first ball, total number of balls are 9. So that means 4 white and 5 red balls. So after you pick the first ball, you replace the ball in the bag. So that means you drop the ball in the bag again. So that means you are getting the 9 ball again in the bag. So that means for the second ball, when we pick the second ball, the bag contains 9 ball again. So that means it doesn't matter whether you pick the first ball or second ball. It doesn't matter. Both event A and event B are independent. So that means the decision of picking the first ball does not affect the decision of the second ball. Since in both cases after replacement, total number of balls will be 9. So let us see the probability of A. That means probability that the first ball is white. So for the probability that the first ball is white, so to find out that one, we need to first in the numerator we need to select 1 white. See, because we are calculating probability that the first ball is white. So out of 9 balls, that out of 4 white balls, we want to get 1 white ball. So that means first white ball. The event that first ball is white. That means we are picking 1 ball for the first time. So we want to get 1 white ball out of 4. So total 4 white balls are there. So out of 4 white balls, we want to pick 1 white ball. So we can do it in 4C1 way. And out of 5 plus 4, total 9 balls. Out of total 9 balls, we want to pick 1 ball. So selecting 1 ball out of total 9 balls is 9C1. So 4C1 divided by 9C1 is equal to 4 by 9. So that means probability of A is 4 by 9. So similarly, probability of B is also 4 by 9, because in the when you pick the second ball, that means probability B means the second ball is also white. like the first ball is white, B is second ball is white, also white. So probability of B, that means probability of getting the second ball is also white. That means when you pick the second ball, getting white is similar like getting first ball white, because you are replacing the ball. That means when you pick the second ball, total balls are same, total number of white balls are also same, total number of white balls are also 4, total number of balls are also 9, so probability will be same like these one. So that means probability of A and probability of B will be same because we are replacing the balls, right? So now the question is asking, what is the probability that both the balls are white? So what is the probability that both the balls are white? That means, when, as I said before, both means when you see the term both, and this means intersection. So this means intersection. Now since probability that both the balls are white, that means P, probability of A intersection B, both means intersection. So probability of A intersection B, that means the formula, from the formula, conditional probability formula, we know that probability of A intersection B is probability of A given B multiplied by the given part, probability of B, right? Since both A and B are independent, because we are replacing it, since you are replacing the ball, so it doesn't matter in the first, it doesn't matter whether you get the first ball white or whether you get the second ball white, it doesn't matter. Both probability of A and probability of B are same because we are replacing the ball. So if you get the first ball white also, after you get the first ball white, you are replacing the ball in the bag. So that means total number of white balls are same, total number of balls are also same. So that means probability of B does not affected by probability of A. So both the events are independent. So that means probability of A does not affected by probability of B. So that means probability of A is independent than probability of B. So that means probability of A given B is probability of A. That means probability of A does not affected by probability of B. So that's why probability of A given B is probability of A. So since the events are independent, so that means this one is probability of A. So that means probability of A intersection B is, this one is probability of A, this one is probability of B, which means 4 by 9 into 4 by 9, 16 by 81. Now let us solve the second part. What about if we do it without replacement? In that case, when you pick the first ball, probability of getting the first white ball, so probability of getting the first white ball will be same like 4 by 9. But when you see, when you pick the first ball, when you get the first ball white, you are not replacing. So when you pick the first ball white, now you are not replacing. So that means we had total 4 white balls. Since you are not replacing, now the 3 white balls are left. So I'm saying again, we had total 4 white balls. Out of 4 white balls, in the first chance, you already picked 1 white ball. So you already picked 1 white ball, so that means only 3 white balls are left. And total, since you are not replacing the ball in the bag, so total balls are now 8. When you pick the second ball, you have 3 white balls and total balls are 8. So probability of getting second white ball is 3 by 8. So that means probability of getting second ball white given that first ball is white. So probability of getting second ball white, that means probability of B given that first ball is already white. So if the first ball is already white, you are left with only 3 white balls. So you are left with only 3 white balls and total number of balls are 8 only. So that means probability of B given A is 3 by 8. So now probability of A intersection B is probability of B given A multiplied by the given part, that means probability of A. So it means probability of B given A is 3 by 8 and probability of A is 4 by 9. So if you calculate it, you will get 1 upon 6. Now we will move to page 19. Let's see what we have in page 19. A hamburger chain found that 75% of all customers use mustard 80% use ketchup and 65% use both. So what is the probability that a customer will use at least one of these? So at least one of these means they will use either mustard or ketchup or both. So that means we need to find the union. So I'm saying again, what is the probability that a customer will use at least one of these? That means at least mustard or ketchup or both. So let A be the event that customer uses mustard and B be the event that customer uses ketchup. So probability of A, we see that 75% of all customers use mustard. So probability of using mustard is 75%, that is 0.75. Probability of ketchup uses is 80%, that means 0.80. And 65% use both. As you know already, both means intersection. So that means probability of using mustard intersection ketchup, that means probability of A intersection B is equal to 65%, is equal to 65%. That means 0.65. Now the question is asking, as I said before, what is the probability that a customer will use at least one of these two options? That means what is the probability that a customer will use at least mustard or ketchup or probably both? So that means union. So you need to find out the probability of A union B, which is probability of A plus probability of B minus probability of A intersection B. So if you put the values there, that is 90% customers will use at least one of the two. Now the second question is asking, what is the probability that a ketchup user uses mustard? That means what is the probability that a ketchup user, that means user, normally the customer use ketchup. Now what is the probability that the customer will use mustard? That means what is the probability that a ketchup user uses mustard and that a mustard user uses ketchup? So that means question is asking you to find out what is the probability that ketchup means event B. That means what is the probability of B given that mustard is A. That means what is the probability that that means you need to find out the probability that a ketchup means event B. That means probability of B given that mustard is A. That means probability of B given that A. And again here you need to find out the probability that a mustard user uses ketchup. That means mustard means A. That means probably you need to find out the probability of A given that user use ketchup. That means B. That means you need to find out the probability that a I was wrong. So that means you need to find out so the question is asking what is the probability that a ketchup user uses mustard. That means you need to find out that the user normally use ketchup. What is the probability that the customer will use mustard now? That means you need to find out the probability of using mustard. You need to find out the probability of using mustard given that user use ketchup. That means mustard is A and ketchup is B. That means you need to find out the probability that the customer will use mustard. That means probability of A given that customer use ketchup. That means B. That means probability of A given that B. And here you need to find out that customer normally use mustard, but now you need to find out what is the probability of using ketchup. That means even B given that customer normally use mustard. That means you need to find out the probability of B given that customer use mustard. That means probability, that means A. That means probability of B, that means you need to find out the probability of B given that A, that means user use mustard. So to find out this one, it's better if we develop a table. So as you can see, the question said that probability of A is 75%. So mustard, that means probability of A is 75%, that means 0.75. Probability of B is 80%. So probability of B means ketchup. Probability of B is 80%. Probability of B is 80%. So ketchup, that means B is 80%. And as you know already, total probability is 1. Total probability is always 1. Now, we also know from the question probability of A intersection B. That means probability of using both ketchup and mustard. So probability of using both mustard and ketchup is 65%. So both mustard and ketchup is 65%. That means 0.65. So that means this is 0.65. Probability of using both A and B. That means 0.65. So if this one is 0.80 and if this one is 0.65, so obviously this one will be 0.15 because this is the total. So if total is 0.80, this one is 0.65, so this one will be 0.15. Again, if this one is 0.80 and total is 1, so this one is 0.20, right? So if the total is 1, if this one is 0.75, so that means this one should be 0.25 because total is 1. Again, if total is 0.25 and this one is 0.15, so this one would be, so total is 0.25, this one is 0.15, so this one will be 0.10. Again, if this one is 0.10 and total is 0.20, so this one will be 0.10. So like this way we can fill out the empty cells of this table, right? Now we will turn over the page. Let us move to page 20. The question was asking probability that, so the question was asking probability that ketchup user uses mustard. So the question was asking that in the first part the question was asking probability that a ketchup user uses mustard. So we will solve this one first. So probability that ketchup user, that means B, uses mustard. That means A. That means we need to find out the probability of A given that B. So that means probability of using mustard. So a ketchup user uses mustard. So that means probability, we need to find out the probability of using mustard given that customer is a ketchup user. So I'm saying again, we need to find out the probability of using mustard. Probability of using mustard given that customer is normally a ketchup user. So probability of using mustard given that customer is a ketchup user. So that means probability of A given that B. A given that B. So as you know from the conditional probability formula, probability of A given B is probability of A intersection B divided by the given part, which is B. So probability of B. And we have already calculated that, we have already got it from the question. Probability of A intersection B is 0.65. Probability of B is 0.80. So answer is 0.8125. Now the second part, the question was asking probability that a mustard user uses ketchup. So probability that a mustard user uses ketchup. So that means probability of using ketchup, we need to find out the probability of using ketchup given that customer is a mustard user. Given that customer is a mustard user. So that means probability of B given A, same. So probability of B given A means probability of B intersection A, which is similar to probability of A intersection B divided by given part. That means probability of A. So probability of A intersection B is 0.65. Probability of A is 0.75. If we divide it, we get 0.8667. Now we will move to page 21. So what we have in page 21. So in this example, what we see, if the conditional probability of mustard uses given ketchup uses, that means probability of A given B is 0.723 and the probability of ketchup uses, that means probability of B is 0.65, then what is the joint probability of both mustard and ketchup uses? That means what is the probability of A intersection B? So from the question we get this one, we get this one. The question is asking what is the probability of A intersection B. So from the formula we know that probability of A intersection B is probability of A given B multiplied by the given part. So if we put the values there, this is the answer. Very easy question. Now the next example, what we have, please complete the following table. Table has been already completed. I mean, usually you will not have all this information in the question. I already filled it out. Here only few information was given. So here probability of T1 given H1. That means probability of T1 given H1 was 0.90, right? So probability of T1 given H1 was 0.90. This is given in the question. Probability of T2 given H1 is 0.10. This is also given in the question. So as you can see, here, this is also given H1, this is also given H1, this one is 0.90. So that means probability of T1 H1, so probability of T2 H2 is equal to 1 minus 0.90, that is 0.10. So here in this example, you will get only these three information available. So that means only these three information was available. So using these three information, you have to fill out the full table, right? So using only these three information, the circle one, that means using only these three information, you have to fill out the full table. So the first one is saying that probability of T1 given H1 is 0.90. So see here a H1, so that means probability of T1 H1, that means out of H1 T1 is 90. That means out of H1 T1 is 0.90. So that means out of H1 T2 will be 0.10. I'm saying again, out of H1 T1 is probability of T1, out of H1 probability of T1 is 0.90. So out of H1 probability of T2 should be the 0.10 because total probability is always 1. So again, out of H2 probability of T1 is 0.10. So again, out of H2 probability of T2 should be 0.90 because total probability is 1, right? Probability of H1 is equal to 0.10. So obviously, if the probability of H1 is 0.10, then probability of H2 should be 1 minus probability of H1. That means 1 minus 0.10, that is 0.90. So here it's saying that table H1 means HIB positive. H2 means not HIB positive. That means obviously H2 is complementary even than H1. So if H1 is 0.10, that means probability of H1 is 0.10. In that case, probability of H2 should be, that means not HIB, should be 1 minus 0.10, that means 0.90 because total probability is 1. Again, if T1 out of H1, so that means this is H1. So if T1 out of H1 is 0.90, that means if the probability of T1 out of H1 is 0.90, in that case T2 out of H1 should be 0.10. That means total probability is 1. That means if this one is 0.90, so this should be 0.10 because here also H1, here also H1. That means out of H1 T1 is 0.90. So out of H1 again, so T2 is only left, so T2 should be 0.10. Out of H2 T1 is 0.10. So out of H2 T2 is only left, so T2 should be, this one is 0.10, so this one should be 0.90 because total probability is 1. This one has been explained already. So we know that probability of T1 intersection H1, the formula is probability of T1 given H1 multiplied by probability of H1, the given part. So that means probability of T1 H1 we already know 0.90, probability of H1 is 0.10, so that means 0.09. So probability of T1 intersection H1, that means both T1 and H1. So that means this is T1 and this is H1, that is both T1 and H1 is 0.09. Both T1 and H1 is 0.09, so this is 0.09 here. So since the total is 0.10 given in the question, probability of H1 is 0.10, probability of H1, that means total is 0.1, probability of H1 is 0.10, that means probability of H1, that means total is 0.10, and this one is 0.09, so obviously this one is 0.10 minus 0.09, that is 0.01. Now probability of T2H2, so probability of T2H2 means probability of T2 given H2, that means T2 given H2 multiplied by the given part, that means probability of H2. So probability of T2H2 we already know T2H2 is 0.90, and probability of H2 we have calculated 0.90, so 0.90 multiplied by 0.90, that is 0.881. So this is T2H2. So T2H2, you can see this is T2 and this is H2, that means this one is the T2 and H2. So this one is the cell for T2 and H2, that means this means T2 and H2, that means T2 intersection H2, 0.81 should be here, because this is the corresponding column for HT2, this is the corresponding row for H2, there is 0.81. So we already know total is 1, so if this one is 0.1 and total is 1, this one should be 0.90, and again if this one is 0.81 and this one is 0.9, so obviously this one should be 0.90 minus 0.81, so 0.09. Again this one is 0.1, what is that called, this one is 0.01, this one is 0.01, so that means this one is 0.09. So if, and again 0.81 plus 0.01 is 0.82. If this one is 0.82 and this total is 1, so this one is 0.18. If this one is 0.18, obviously, so this one should be, then this one is 0.09, so obviously this one should be 0.09. This one should be 0.09. So this way we can fill out the table, right? So now we will study Bayes theorem. So we know that probability of A intersection B is equal to probability of A given B multiplied by the given part, that is probability of B. Again this one can be written in reverse way. So that means probability of B given A, if you write it like this way, probability of B given A, then you need to multiply it by the given part, that means probability of A. That means probability of A given B, you can take either A given B, probability of A, when you calculate probability of A intersection B, you can take A first and given B, then you need to take the multiplied by the given part, that means probability of B. If you reverse it, that means if you take B first and given A, that means if you take B first, that means probability of B given A, in that case also you need to multiply it by the given part, that means probability of A. So both are same. So now this one equals this one. So if you keep this one in this side, that means probability of A given B, in that case this one will move in the right hand side. So this one is in the multiplication condition. If it moves in the right hand side, it will go in the denominator. That means we will divide this part by probability of B. So that means probability of B given A multiplied by probability of A will be in the numerator, and this one will go below. That means in the denominator, probability of B. So that means this is called Bayes theorem of probability. So probability of A given B can be written in the reverse way. That means B given A. That means probability of B given A and all multiplied by the given part. Always will be multiplied by the given part. That means probability of A. And the given part that means probability of B will be in the denominator. That means probability of A given B can be calculated from the reverse conditional probability. That means probability of B given A multiplied by the probability of A, and in that case you have to divide it by the probability of the given part, that means probability of B. So similarly, if you write the formula for probability of B given A, in that case, according to Bayes' theorem, in the right hand side we will have the reverse one, that means probability of A given B, probability of A given B multiplied by the probability of B divided by the given part, that means probability of A. Similarly, if you write the formula for this one, probability of C given D according to Bayes' theorem, so if you write the formula for probability of C given D, that means probability of C given D is probability of reverse, that means D given C multiplied by the given part, that means probability of C divided by the this one, probability of D. Again, if you write it like this one, probability of A given M should be equal to probability of M given A multiplied by the probability of A, the given part, divided by the probability of M. So this way we can write. Now we will move to page 23. So let's see what we have in this example. Based on an examination of past records of a corporation's account balances, an auditor finds that 15% have contained errors. So of those balances in error, 60% were regarded as unusual values based on historical figures. Of all the account balances, 20% were unusual values. If the figure for a particular balance appear unusual on this basis, what is the probability that it is in error? So let me read out the question again. Based on an examination of past records of a corporation's account balances, an auditor finds that 15% accounts have contained errors. So that means auditor normally inspect all the accounts of corporations, of different companies, etc. So an auditor finds that 15% of that corporation's account balances have contained errors. Of those balances in error, 60% were regarded as unusual values. That means out of the account balances, out of the account balances, out of the account balances, 15% these account balances, 60% were regarded as unusual values. That means, those accounts were found in errors. Of those account, from those account, 60% were regarded as unusual values based on historical figures. Of all the account balances, 20% were unusual values. Then out of all the account balances, 20% were found as unusual values. If the figure for a particular balance appears unusual, on this basis, what is the probability that it is in error? So let us define the events first. So let A is the event that error in account balance. So that means if there is any error in the account balance, so we name that event as A. B is the event where the account balances have unusual values. That means B is unusual value based on historical figures. So that means B is the event that represent account balances with unusual value based on historical figure. So as we can see from the question that 15% have contained errors. So that means 15% accounts got errors. So that means probability of A, that means the event that error in account balance. So we have seen that 15% accounts are in error. So that means probability of A is 15%. Right. Next one is saying that of those balances in error, that means out of those erotic account balances, that means out of those wrong account balances, 60% were regarded as unusual. So that means 60%, this is the probability of getting unusual values. This is the probability of getting unusual values in the accounts out of the out of those accounts were found in errors. That means out of the account balances were found in error of from those account balances 16%. That means this is the probability of B by A. That means probability of unusual value out of accounts in errors. That means this 60% is the probability of unusual value based on historical figure out of the accounts those out of those accounts already found in errors. That means out of those account already found in error, 60% were regarded as unusual value. So that means 60% accounts were found in 60% accounts are found in with unusual value. 60% accounts are found with unusual values out of the accounts with error. Out of the accounts with errors. That means probability of B given A is 60%. Right. Of all the account balance, that means out of all the account balance, 20% were unusual values. So that means probability of B, that means B is the unusual values. So probability of B is 20%. That means 0.20. Right. So probability of the question is asking if the figure for a particular balance appear unusual on this basis. If the figure for a particular balance appears unusual on this basis, what is the probability that it is in errors? That means we need to find out the probability that the account balance is in error, provided that it is already unusual. It is already contains unusual values. That means we need to find out the probability of A given B. So that means we need to find out the probability of A given B. That means probability that the account balance is in error given that it appears unusual. So A given B. So from the Bayes theorem we know that probability of C, to find out these one we already have B given A, but we need to find out A given B. So A given B is the reverse of B given A. So that means we can use these one to find these one using Bayes theorem. So that means probability of A given B is equal to probability of B given A, that means reverse one, multiplied by the given one, that means probability of A, divided by this given part, that means probability of B. This is Bayes theorem. That means if you have the reverse conditional probability, you can use Bayes theorem to find out that. That means if you want to find out A given B, probability of A given B from probability of B given A, we need to use this formula, that means Bayes theorem. So if we put the values there and calculate, we get 45%. That means 45% is that means probability of getting account balance in error given that it appears unusual is 45%. Now we will move to next page, page 24. Page 24. So here we have an example. Let's see what this says. A car dealership knows from past experience that 10% of the people who come into the showroom and talk to a salesperson will eventually purchase a car. That means the car dealership is making 10% sale from customers. So 10% sale, that means car dealership is from their experience, they know that 10% of the people who come into the showroom and talk to a salesperson will eventually purchase a car. That means if 100 customers come into the showroom and talk to salesperson, out of 100 customers only 10 customers will actually buy the car, So the dealer conducted a promotional offer of a free dinner with salesperson and got the following result. So that means the dealer experimented a promotional offer of a free dinner with salesperson and got the following result. So the result shows that 40% of the people who purchased cars had a free dinner. That means 40% of the people who purchased cars, that means those who purchased cars, out of them 40% had free dinner, right? 10% of the people who didn't purchase cars had a free dinner, right? The first question is, do people who accept the dinner have a higher probability of purchasing a new car? Right. The second question is asking, what is the probability that a person who does not accept a free dinner will purchase a car? So let us first name the events. So let D1 is the event that customer has dinner with salesperson. So D1 is the event that customer has dinner with salesperson. So D2 is complementary of D1. So that means D2 is customer doesn't have dinner with salesperson. Since D1 is customer has dinner with salesperson, so D2 will be customer doesn't have dinner with salesperson. That means complementary of D1, right? So P1 is customer purchase a new car. So P2 is complementary of P1. So that means customer does not purchase a new car. So from the question we can see that probability of purchasing a car is 10%. So probability of P1, that means purchasing a new car, probability of P1 is 10%. So obviously probability of P2 will be, if this is 10%, so probability of P2 will be 90%, that means 0.90, right? Now here the question said that 40% of the people who purchased cars had a free dinner, right? That means out of the customers who purchased cars had a free dinner, right? So that means probability of D1 P1, that means probability of D1 P1 is 40%. That means 40% of the people who purchased cars, then out of the people who purchased cars, only 40% had free dinner. That means 40% is the probability of a free dinner. 40% is the probability of receiving a free dinner out of the people who purchased cars. That means 40% is the probability of getting a free dinner out of the people who purchased cars. That means 40% is the probability of free dinner given that customer purchased cars. So that means this is the probability of free dinner given that customer purchased cars. So probability of free dinner given that customer purchased cars. That means out of P1 is the purchased cars. Then out of the customers, out of total customers who purchased cars, this is the percentage of people who had dinner. That is, this is 40%. Now next one, 10% of the people who didn't purchase cars had a free dinner. So that means 10% is the probability of receiving a free dinner out of or given that they didn't purchase cars. So didn't purchase cars means P2. That means D1 P2. That means probability of D1 given P2. That means out of the people who didn't, P2 means didn't purchase cars. That means out of the people who didn't purchase cars, that means P2, only 10% people had free dinner. That means D1. So probability of D1 P2 is 10%. That is 0.10. Now the first question is asking, do people who accept the dinner have a higher probability of purchasing a car? Normally 10% people only purchase car. Normally only 10% people purchase car. So we need to find out that whether, that means do people who accept the dinner have a higher probability of purchasing a car? That means we need to see after the dinner offer, we need to see that if the customers are purchasing more cars, that means if we need to find out if more customers are purchasing car after having the dinner offer. That means whether the dinner offer is successful or not. If the dinner offer is successful, then more customers should buy car. Now at present, before dinner offer, only 10% customers are buying car. So if we see that more than 10% customers are buying car after receiving the dinner offer, then we can say that the dinner offer is successful. So in the first part, we need to find out that one. That means we need to find out the probability of purchase given that customer had dinner. That means we need to find out that probability of purchase given that customer had a dinner. That means we need to see after receiving the dinner whether the probability of purchase has improved or not. So we need to find out the probability of P1 given D1. Right. So let's see. So that means we need to find out the probability of P1 given D1. Right. We can find out this one using the Bayes theorem. That means opposite of conditional probability. That means P1 D1. We can use probability of D1 given P1 multiplied by probability of P1. That means this one, the given part, divided by the given part, that means probability of D1. We can use this formula, but here we can also solve it using simplest way. So let's see. We can solve it using this table method. So we know that total probability is 1, and we know that probability of purchase, probability of P1 is 10%. So probability of P1, that means purchase, is 10%. So if probability of purchase is 10%, so not purchase or probability of P2 should be 90%. That means 0.90. That means if this one is 0.1 and total is 1, so this one should be 0.90. Right. Now as you can see, we have probability of D1 P1, which is 40%. So probability of D1 P1, we know that probability of D1 P1 is equal to probability of D intersection P1. That means D1 P1, probability of D1 given P1 is probability of D1 intersection P1 divided by the probability of the given part, that means P1. Right. So that means probability of D1 intersection P1, probability of D1 intersection P1 can be written as probability of D1 given P1 multiplied by the given part, that means probability of P1. We already know probability of D1 P1, probability of D1 P1 is 40%. So probability of D1 P1 is 0.40 and probability of P1 is 10%, which is 0.10. So if you multiply 0.04. So this is probability of D1 intersection P1, that means 0.04. So D1 intersection P1, that means D1 P1. So you can see this is D1 and this is P1. That means D1 intersection P1 is this one, 0.04. So we will put the value there. That means 0.04. Probability of D1 intersection P1 is 0.04. That means both D1 and P1. That means this is both D1 and P1, 0.04. So as you see, if this one is 0.10 and if this one is 0.04, so obviously total is 0.10 and this one is 0.04. So obviously this is 0.06. Right. So next we have information, this one, probability of D1 P2 is 10%. So probability of D1 given P2. So probability of D1 intersection P2. So probability of D1 intersection P2 is equal to, we can write it like probability of D1 given P2, probability of D1 given P2 multiplied by probability of P2. So probability of D1 intersection P2, similarly like this one. So probability of D1 intersection P2, we can write it like probability of D1 given P2, so D1 given P2 multiplied by the given part, that means probability of P2. And probability of D1 P2 is already given in the question. This is 10%, that means 0.1. So probability of D1 P2 is 10%, 0.1. And probability of P2, we know that probability of P2 is 90% or 0.90. So 0.90. If we multiply, we get 0.09. So this is probability of D1 intersection P2. That means both D1 and P2. That means probability of D1 and P2. So this is the D1 row and this is the column for P2. So this is D1 P2. both D1, this cell represents both D1 and P2, that is D1 intersection P2. So we got the result is D1 intersection P2 is 0.09, we will put it there, 0.09. So since the total is 0.90 and this one is 0.09, so this one will be 0.81. Now we already got this 1.04, we already got this 1.09, so total will be column, this row total will be 9 plus 4, that means 0.13. We already got this 1.81, we already got this 1.06, so this row total will be 0.87, and we already know this one. So we got the table. Now, as I said before, for the first question, we need to find out the probability of P1 given D1. So now we can see probability of P1 given D1, we can do it in two different ways. We can find it using Bayes theorem, that means the reverse conditional probability. Here we have P1 given D1. So if you use Bayes theorem, we have to use the reverse one, that means probability of D1 given P1. D1 given P1 multiplied by the given one, that is probability of P1, and this one is given one is D1, this one will be in the denominator, probability of D1. So if you put the value, the answer is 0.30769. Alternatively, we can also find it, you know that probability of P1 given D1 can be also found using this formula. Probability of P1 intersection D1, probability of P1 intersection D1 divided by the given part, divided by the probability of D1. We already know P1 intersection D1. So this is P1 intersection D1 is equal to 0.04. That is 0.04. Probability of D1. This is the row for D1. So probability of D1 is 0.13. So probability of D1 is 0.13. If you divide, you see, you get same answer, 0.30769. Here also 0.30769. So you can solve it in either way. So if you round it, we get 30.77%. So as you know that probability of purchase before the dinner offer was 10%. That means only 10% customer was buying car. That means only 10% people who come and talk to salesperson usually buy car. That means only 10% of the people who buy to the that car dealership. That means only 10% people who come and talk to salesperson used to buy car. But after the dinner offer, that means probability of purchase given that customer had dinner. So probability of purchase, this is P1 is purchase, and given that D1 is dinner, that means probability of purchase given that customer had a dinner with salesperson is 30%, 30.77%. That means after getting dinner with salesperson, sales of car has increased to 30.77%. That means the dinner offer was very good. That means the sales of car sales has been increased by almost threefold. That means almost 3 times. Probably the salesperson is very capable, or maybe the car dealership hired a very beautiful lady to influence customers to buy car. Don't know. Now the second part. The second question was asking what is the probability that a person who does not accept a free dinner will purchase a car? That means we need to find out the probability of purchase. That means we need to find out the probability of purchase given that customer didn't accept dinner. That means we need to find out the probability of purchase that without having the dinner. Probability of purchase without having dinner. Right. So that means we need to find out the probability of purchase, that is P1, given that customer didn't have dinner. Right. So you can find out using this formula. So probability of P1 given D1 can be we can find it like probability of P1 intersection D2 divided by probability of D2. So probability of P1 intersection D2. So probability of P1 intersection D2. From the table we can see this is the P1 and this is D2. So probability of P1 D2 is 0.06. So probability of P1 intersection D2 is 0.06 and probability of D2. So probability of D2 from the table we can see 0.87. Probability of D2, this is the D2 row, so probability of D2 is 0.87. So probability of D2 is 0.87. If you divide, we get 6.896%. Usually 10% customers who come and talk to salesperson buy car, right? Usually 10% people who come and talk to salesperson will buy car. But we can see that those who refuse to have dinner will buy on, that means those who refuse to have dinner, out of those people only 6%, only 6.89%, so around 8, only 7%, around 7% people are buying car. So we see that those who refuse the dinner have a lower probability of purchase. Normally 10% people buy car without before the dinner offer. But we can see that those who refuse to have dinner have a lower probability of purchase. Now we will move to page 27, random variables. So let's see what is random variable. So a random variable is a numerical outcome of an experiment. So random variables can be discrete, that means countable number of values, or continuous, that means any value within a range. So we will call a variable random when it is associated with a probability. That means we will call a variable random when the variable comes with a probability. When the variable comes with a probability, that means when we do an experiment, when we get numerical outcome of an experiment, that can be called as numerical variable. Random variable. So when we do an experiment, the numerical outcome of that experiment can be called as random variable. Normally random variable comes with probability. So random variables can be discrete. That means when the values are countable. That means when the random variable comes with countable number of values. That means 1, 2, 3, 0, 1, 2, 3, 4, 5, like that. So when the values are countable, then we will call it discrete. But when the values are but random variable can be continuous when the value lies within a range. So let us check out some examples of discrete random variables. So suppose we do the following experiments. Suppose we contact 5 customers. So suppose we contact 5 customers to see whether the customer purchase goods or not. So this is our experiment. We are contacting 5 customers. So the random variable can be number of customers who place an order. That means number of customers who actually purchase. So that means we are contacting 5 customers. Out of these 5 customers, probably no customer will purchase, probably 1 customer will purchase, probably 2 customer will purchase, probably 3, probably 4, probably 5, all customers will purchase. So the possible values of the random variable can be 0 to total 5, 0 to 5. Suppose we are doing an experiment, that means we are inspecting a shipment of 50 radios. So suppose you have received a shipment of 50 radios. So as usual, when you receive the shipment, you need to check whether the goods are good or bad. That means whether the goods are defective or not defective. So that means number of defective radios. So the random variable can be number of defective radios. So you are experimenting total 50 radios. So probably you may have 0 defective radios, you may have 1 defective radios, you may have 2 defective radios, you may have 3 defective radios. Like that way you may have up to 50 defective radios. So these are the possible values of random variable in this case. So in this one we are operating a restaurant for 1 day. So this is another experiment. So in this experiment, we are operating a restaurant for one day to see how it goes. So the number of customers can be the random variable. So you may receive that particular day 0 customer, that means no customer. You may receive 1 customer, you may receive 2 customers. Like that way, you may receive numerous numbers of customers. Suppose we can do another experiment like sell an automobile. So if you sell an automobile, the random variable can be possible values of that automobile. That means possible values of that vehicle. So you may sell the vehicle at the price of $2,000 or $2,500 or $3,000 or like that way. So these are the examples of discrete random variables. Right. So expected value and variance of a random variables. So what is expected value? The expected value is the mean or average of a random variable. So the expected value is the mean or average of a random variable. We know how to calculate the average of a normal discrete variable, but this one is not normal discrete variable. This one is random discrete variable. So that means this one is discrete random variable. So when it is a discrete random variable, we need to calculate average or mean using the following formula. So the expected value is the mean or average of a random variable x. So here the variable is x associated with probability x. So that means as I said before, random variable comes with a probability. So when you see that probability is attached with the variable, that means this is a random variable, and in that case, if you want to find out the average of that variable, you have to use following formula. So the expected value or average value of the random variable is, expected value means E bracket x, E means expected. So E bracket x is equal to summation of x multiplied by probability. Multiplied by probability means probability of x. So summation of x multiplied by probability of x. And the formula for variance is sigma square is equal to summation of x square multiplied by the probability minus expected value of x, that means this one, expected value of x square. Right. So if we solve a question, you will get clear picture how to solve this. Suppose we have a question here. Following data shows sales of automobiles over the past 300 days at DeCarlo Motors in Saratoga, New York. So that means a particular automobile shop in Saratoga, New York has observed, has collected 300 days data. That means they have collected their historical sales data over the last 300 days. So that means this automobile company, they have collected their historical sales data over the last 300 days. So this is the data. So they have seen that among the 300 days, out of these 300 days, they couldn't sell a single car 54 days. That means out of these 300 days, 54 days has gone. That means out of these 300 days, they have seen that 54 days they couldn't sell a single car. They have seen that 117 days they sold only one car. That means 54 days they couldn't sell a single car. 117 days they sold only one car per day. That means 117 days they have sold one car per day. That means total 117 cars. 72 days they have sold 2 cars per day. 42 days they have sold 3 cars per day. 12 days, out of these 300 days, there were total 12 days they sold 4 cars each day. Out of these 300 days, they got 3 days where they sold 5 cars each day. So we need to find out the probability. So this is total number of days is 300. This is 54. So that means probability of selling 0 car. That means probability of selling 0 car is equal to 54 divided by 300. That means 54 divided by 300 is 0.18. So probability of selling 1 car per day, probability of selling 1 car per day is 117 divided by 300. 117 divided by 300, 0.39. Probability of selling 2 car per day is 72 divided by 300. That is this one. So like that way you can calculate probabilities of selling every single possible cars. That means probability of selling 1 car, probability of selling 2 car, probability of selling 3 cars per day, probability of selling 4 cars per day, probability of selling 5 cars per day, you can calculate. So this is the outcomes. So this is the outcomes. Outcomes are 0 cars, 1 cars, 2 cars, 3 cars, 4 cars, 5 cars. So these are the outcomes. We call it variable X. And this variable X comes with probability also, right? So this is random variable. Since this variable comes with probability, we will call this variable as random variable. So the formula for expected value is Ex is equal to summation of xpx. That means we need to multiply x with probability. That means we need to multiply 0 with the probability 0.18. So if you multiply 0 with probability 0.18, you get 0. If you multiply 1 with the probability 0.39, you get 0.39. If you multiply 2 with the probability 0.24, you get 0.48. If you multiply 3 with its corresponding probability 0.14, you get 0.42. Like that way, you need to multiply each outcome with its corresponding probability. So you get this one. So if you get the total, of this column, this is 1.5. That means this is the summation of xpx. So this 1.50 is the summation or total of xpx. So expected value of x, that means summation of xpx is 1.50. Right. So to find variance, we need to find out summation of x square multiplied by probability. So that means we need to do another column for variance, x square px. That means square of this value multiplied by 0.18. So 0 square means 0 multiplied by 0.18, 0. 1 square means 1 multiplied by 0.39 is 0.39. 2 square means 4. That means 2 square multiplied by 0.24. That means 2 square is 4. That means 4 multiplied by 0.24 is this one. 3 square is 9 multiplied by 0.14 probability. That is this one. 4 square is 16 multiplied by probability. That is 0.04 is this one is 0.64. This one is 0.64. Sorry for the not clear. Sorry for not having clear picture here. This one is 0.64. So in that way you will calculate some x square px for each rows, and if you add all this is the summation of or total of x square px or summation of x square px, that is 3.5. So the formula for variance is summation of x square px minus expected value of x whole square. So summation of x square px, we got 3.5. This is 3.5 minus expected value of x. This is expected value of x is 1.50. So 1.50 square. So if you calculate, variance is 1.25. Now standard deviation, you know it. You know already. Standard deviation is root over variance. So root over sigma square. That is root over 1.25. That is 1.118. So that's the end of probability chapter.